Hello, welcome back to BLENDERSUSHI. In today live noding, I will be going through more on animations, kind of like fundamental. Um, it's more on the animation mixing. So I'll just quickly go to the compositing layout. So I'll just show you. So previously I have already mentioned to you that you can animate using this 1, 2, 3, 4, 5, 6 different nodes. Animate matrix dealing with the transformations of the objects. Vector, tree values. Animate floats, just numbers. Animate color, Euler, quaternion for rotations. Color is obviously to animate colors. And these 6 nodes will be really handy because it provides you with the durations and then also the interpolations type. I also have shown you that you can use the mixer nodes, but I didn't mention about the list mixer mix. So here you have 1, 2, 3. You actually have 7 because there's like mixed interpolation as well. That's kind of like a special node that allows you to mix, like say you need to mix linear interpolations and circular interpolations. You can do that, maybe to kind of influence the speed of the animations. I want to show you a couple of things. So before I show you what you can do with a mix list, you can actually kind of like a piggyback like a mix node right here. So before we jump into the list is can be more robust, but depends on what you're doing. We can say, let's say I'm using mix vectors here. So it's gonna be super basic, but also I found it really interesting. Yeah, let's say you have these objects here, and let's make the x-axis facing that way. So I want the objects to move from 0, 0, 0 to 5, 0, 0. Okay, 0, 0 to 5, 0, 0, and I need to have like object transform output. I'll grab that object and then I turn on the locations because I want to animate these objects, but using the mix vectors. The good thing about these procedural animation nodes is that we don't need to worry about looping yet. You can loop stuff and do some clever things, but this is like super simple. You don't need to think about looping at this moment. So mix vectors, I'm basically mixing like the original position and the end positions from A to B. Okay, and I can animate the factor. You see, with a mixed vectors, you can actually goes beyond the minimum and the maximums, but you can actually clamp it, so it goes from 0 to 1, kind of like normalizing the value if that's what you want. That's better. So it goes from point A to point B. Okay, that's really simple. However, you can also piggyback this thing if you want to have multiple positions. That's actually what you're gonna learn from this video tutorials. You can have multiple positions. Let's have like 4 different positions for now. Okay, supposedly, so it's from 0, 0, 0 and it will end at 5, 0, 0. If we plug in this guy into that guy, that's gonna be the start positions for the next animations. And then so if you wanna, now if I, so it's 5, 5, let me try to think. I think so it goes from 0, 0, 0 to 5, 5, 5. We can go to 0, 0, 0 to 5, 5, 0. 0002550. Okay, we have apparently need to turn off the clamp factor. Oh wait, I made a mistake. So yeah, the results needs to go that. So that's what we need. Okay. So from 000 to 1, and then here once again we need to start from 000 to 1, and then next if you wanna you wanna move it to this position, it's gonna be 0 0. We have to try to think. That's what I mean by piggybacking. It's a little bit complicated, but not really. So you have this position, and then you got one position, second positions, third position, and fourth positions. This is gonna be maybe 555, but then again you want to go back to 000, I guess. So it's 05, 50, 55, 05. We're not gonna animate in Z. It's gonna be adding unnecessary complexity. But this one can go that. This one can go that way. So 0 to 1, and then 0 to 1. Okay, so it's four different positions, and by doing that we're kind of making a loop. Like it goes this way and then goes up and goes that way and back to original positions. Let me get rid of the grease pencil. You could have like a clever looping that's actually take advantage of this 0 to 1, 0 to 1, 0 to 1. You know, like to create animation, 0 to 1, 0 to 1, 0 to 1, 0 to 1. That can be loop, but I'm not gonna do that. Instead, we're gonna use a mix vector list. Mix vector list, and here we have like instead of doing this piggyback kind of thing, we're gonna use list of vector, and just this single node is gonna mix everything together. Let's see how we're gonna do that. So it's required vector list, so you just type in vector list math. That's interesting. Vector list math. Never thought about this. Vector list. Create vector list. That's what we want. Okay, we can have like the 4 position as well, just like this, and just plug that in, and then now we can write down 500 55000. So that's the loop. Actually, let's give it a try. First position, second position, third, fourth position. Actually, I missed one. So it's there's gonna be 55505 back to 000. So you see here, you see the factor here. It goes from 0 to 1, 0 to 1, and from 0 to 1, it's gonna do all these lists. You can make it repeat. So from 0 to 1, go back, and it's gonna keep looping. So that can be really useful, and you can use like a frame for that. Now with a frame number, it goes from 0 to 1 like super fast, so you can't see any animations. You need to math like multiply the frame, so it's maybe like 0.02 or 3 usually, or 4. Now we have like a kind of looping animations. This is, I know this is really basic, but it's really fundamental, and then by doing it this way you can see clearly what you can achieve, you know. Even though we don't have durations like the animate vector, for example, but this is kind of really handy if you have like multiple positions and you want just list it all, just like this. Let me try something else. Let's say since these guys, you know, the positions, they're like vectors, they're 3 numbers, you can take advantage of that by, let's say you if you draw like a line, because in Blender you can just go to edit mode and merge that guy, and then you have a single vector position there, and then you can draw another position there, you know, just like drawing in 3D. You can adjust these positions. So there's how many positions? 1, 2, 3, 4, 5, 6, 7. 7, or we can have more. This is kind of like a motion path animations. However, it's more about one position to the next Okay. I can delete these. Okay, let's save this. It's gonna be an mix list anim 001. Save it and then save another version. So we can reference this line and turn it into like a path for this guy. I'm gonna delete this. So here, instead of having like a big list of create vector list, we can simply type in the number, the vectors positions, the point position of this line. Okay, just use object mesh data and just source that guy, and then plug it in. And now let's have a look. So yeah, it's moving from there. Okay, it seems to be making a big jump there. Maybe the order of vertices is not correct. 1, 2, 3, 4, 5, 6. Somehow it might be doing it, but I don't know. I'm not quite sure. I believe we can display the index number. No, the index number. I'll just use Vertex to display the index number of this line, because the index the index number of the vertices matters to tell you the order of the vector. Turn on Vertex. Vertex has this really useful index viewer, and then let's bring in the objects in, grab the object, plug that in. Index number is showing, but it's yeah, I don't like it, it's not in the right positions, because we need to apply the matrix apply, because this is a very choke, you know, and you gotta apply the matrix, and then now it's correct. Let's see if we can turn on the background. Okay, background black. Okay, that's very clear now. 0 is here. 0, 1, 2, 3, 4, 5, 6, 0. Now with the vertices, actually we can reorder it using Blender. If we tap on go to edit mode, and then we put the cursor there, we can sort the order of the vertex. So sort mesh element from the based on the cursor distance. So I believe it has been updated. Yep, it's been updated. I just need to scrub on the timeline for Spherechalk to update it. So now it's more correct. Start from 0, 1, 2, 3, 4, 4 0, 1, 2, 3, 4, 5, and then it goes back to 0. Okay, because I sort the vertices properly. Alright, so as you can see, this is rather quite simple, but also really useful. Perhaps you have maybe like arrow traveling down the line, and that repeat thing is really useful to loop the animations. Okay. Alright, so this is kind of like a motion path, kind of like a motion path. So I might actually show you. Let's create a cone. I'll show you anyway. I might have talked about this before. If you have a cone and you want to make an arrow, it's super easy. Select face and then extrude it and scale it down, and then extrude it again down. Okay, you got yourself an arrow. I'll scale this arrow a little bit. So get this arrow, and there is a template actually allow you to do like a motion path animation. Distribute instance on spline. Okay, that's the one. This can help you to do the motion path animations. Right, so we need to draw spline first. Let's see. Just draw. Gonna draw a spiral, like a snail spiral, like that, and then convert it. Alt C. No, sorry. Convert to. Convert the curve. Convert the grease pencil to curve, and hopefully did it work? Maybe I didn't do it properly. Check it in the outliner. Didn't work. Do it again. So I select nothing and then just gonna draw like a spiral and convert grease pencil to Bezier. Now I have the curve. I can delete grease pencil, and like we already know this curve is pretty dense, but that's okay. Maybe we can resample it. But anyway, this is our arrow, and we can take the arrow and then okay, this setup actually gonna instance the objects. It's doing this spline sampling as well, so it's not really an animations, but it's doing the sampling. And this loop's gonna instance the objects, but you know what? You can actually use this to animate. Okay, instancing is fun, but you want to animate it. Okay, let's see. I didn't plan this, but we're gonna see. Let's have a look. So we have location list, we have directions. Directions is important. Interpolates the curve. I think all the information is there, but I just can't see it at the moment. Let me hide. Let me have a think a little bit. So the objects is there. We have the objects. In fact, if we turn on and off each instance, it's actually animating. We have locationally, so maybe we can just use a matrix list, mixed matrix list. That's interesting. So, oh, but with this we probably need to create a loop. If we have like vector mixed vector list, so we have the positions right here. We can transform the objects. Let's see, I will create another arrow and I will give it a color. Get the arrow, mix vector, plug that in. So now the arrow is following the path. So that's what we want, but the rotations need a we need a way to rotate it properly. The tangent. Okay, let's try the tangent. There's actually a tangent for multiple points. Okay, maybe it's inside the loop. Interesting. But that's a good exercise for me and you, maybe to find out how to do the motion path thing. That's a good one. Next, I will just gonna show you one more thing. So, animation nodes, okay. It's the, so what did we have before? So the mix, with the mix list we have quaternion, interpolation. Okay, with the list 1, 2, 3, 4, 5, 6. Color, yeah, color can be fun as well. You can have color that kind of like list of colors, and you can animate it one by one from one color to another and loop it. Float for a single number, Euler and quaternion for rotation. Mixed matrix is probably what you like to use. Let's do this one. Let's delete this guy. Let's see. Okay, actually I want the cube. So with the cube, I will probably, let's say I'm scaling it like that, and I have another cube. This I will scale and rotate. This also I will rotate. Scale it in X, S, X. I think you can. I want to rotate it to follow the individual origin. Yep, that's what I want. Scale it like that. And then one more. Here, I believe we can also randomize. so kind of deforming the object like that. Now we can grab the list of those objects and use a create matrix list. Let's see if we can. Okay, we need to do it one by one, I guess. Create matrix list, so just grab the objects matrix, object matrix input, 1, 2, 3. Select that guy and then select this guy. So this is good to demonstrate kind of like a more computational thinking, a little bit technical but simple, you know. Let's make it repeat, and the output is going to be object matrix output. And let's create a monkey head, Suzanne. Let's grab this guy, and then you can see by animating this mixed matrix list, we could kind of animate from one state to another really quickly. And if you want, you can have more. I wonder if Suzanne actually is skewed as well. Probably not. It's only looking at the transform. It's not skewing it. If you want to skew it, you probably want to use let me have a look. Displays mesh deform. Yeah, the mesh deform. I didn't try this, but I'm kind of curious. So what if we put this guy in the center and then we create a cube and then place it in the center. I'm just gonna scale it a little bit just so that it's covering Suzanne. I will now turn it into wire. So now Suzanne modifier is a mesh. Mesh deform is powerful. Okay, it can. So let me try. What's the name? This is cube number 3. This is a deformer cube. I will select that cube and then bind it. Now what's gonna happen is Suzanne head is gonna be deformed just by manipulating the vertices of this object. Let's just wait a little bit. It takes a bit of time. Well, I think with the matrix list, okay, it's done. It's only looking at the transform. It doesn't look at the vertices. So yes, so you see the points of this box is now being affected. And so if I just grab the box and animate it, it's transforming, but it's not. That's not what I want. So forget about that. Delete that. Let's reset it. Reset the position. Reset the scale. With this guy, you probably wanna, if you use something like virtual, let's see, create object mesh in, and select that object and then vector randomize input vertices. You can do this using animation nodes as well, and then output it as bmesh figure mk2. And Suzanne needs to be rebind. Gonna be the alpha, which is the spread shot. I'll save this real quick, and hopefully it doesn't crash. So of course we have like the original objects as a source, and then we randomize the vertices, and we have the output, and the output is this alpha 0. Fingers crossed, hopefully this works. Yeah, so basically today you learn how you can mix multiple lists of positions or transformations, and yeah, so Spreadshot allows you to deform Suzanne like that. Like we can even hide this guy, but that's a totally off topic of what we're talking about, so don't worry about that. Can I delete that? Delete that. So back to where we were before. Animation list. Let's reopen this guy. So how are we going to animate this? I'm just gonna duplicate this once more, and this gonna be green color. Ah, okay. I need to do this. So the green object now, I have this guy. Let's grab that guy. Locations. And the rotations. Grab it. So apparently in order to do this, you need to put that guy inside the loop. Huh. What do you know? And you might, so I think what if we put in a vector list and grab the positions? So we brought in the list of vector and plug that in there, and then put it there. Okay, so it's not working as I wanted. However, I just remember rotations. We have a Euler rotation, Euler mix Euler list, mix Euler list, and we have the tangent here, so we can probably brought in the tangent as well. Mixed, and in fact we don't need to put it inside the loop. So the green cone, we can just mix vector list. So we have mixed vector list, and we just plug in the position, plug that in there, and we have it animating along the lines. And then the mix Euler list, the tangent is actually another vector. Maybe I just need to plug the tangent in there, and plug it into there. It's gonna take care of the rotations. I'm still guessing. I might be wrong, but and just create a float input, and it's gonna be handling the factor. So from 0 to 1. Aha, so so now it's doing the job. Okay, that's exactly what we need. Motion path animations procedurally done, and that's by using the thanks to the mix vector list and also the directions to rotations. That's really handy. Right, so there you go. Animation using, it's a procedural animation using animation nodes, and then we learned today how to mix multiple values, and as a bonus you get this motion path animations that you can loop forever and ever. Alright, so feel do experiment with other like a mix list, like a color that, like I said, color is fun, and then quaternion Euler and quaternion, we rarely create that list, but you can actually use it quite easily here. Alright, hopefully you find this video useful and you can now understand a little bit more about animation mixing. Yeah, I'll see you on the next video. Thank you for